Greetings. My name is Brandon Seymour. I serve as Principal Enterprise Strategist for the AI Factory at CDW. I'm currently pursuing my bachelor's degree in artificial intelligence at the University of Maryland Global Campus. In both roles, I work at the intersection of enterprise infrastructure and applied AI, which brings us directly to today's topic. Imagine an air traffic control tower coordinating hundreds of flights, a power grid at peak demand, a financial exchange at market open, thousands of systems communicating every second. Now imagine a single exploit attempting to move laterally across that environment. Cybersecurity today is no longer perimeter defense, it's machine speed survival. And humans alone can't operate at that speed. Today, I'll show how AI is redefining digital defense, not as software, but as infrastructure. So let's imagine a modern hospital, power grid, or financial exchange. Thousands of systems communicating every second. That attack surface is enormous. In that environment, traditional rule-based security begins to struggle. Artificial intelligence changes cybersecurity because it shifts from rule-based detection to pattern-based inference. Traditional systems rely on signatures. AI instead leverages things like supervised learning for classification of malware detection and phishing identification. Unsupervised learning for anomaly detection, deep learning models for behavioral profiling, natural language processing to analyze phishing emails and social engineering patterns. Ahmed and Taha explained that machine learning models can identify software vulnerabilities directly from source code by learning structural patterns rather than relying on predefined rules. That distinction is foundational. AI is not just matching patterns, it's learning them. From an enterprise AI strategy perspective, this means security becomes data-driven and continuously adaptive, evolving as the environment evolves. Threat detection follows a structured pipeline. Data ingestion for things like telemetry, logs, and network flow. Feature extraction, behavioral modeling, anomaly scoring, automated containment, continuous retraining. But architecture alone doesn't tell the story. What makes this architecture powerful is that it's not event-driven, it's behavior-driven. It continuously learns the statistical distribution of normal activity and flag deviations in real time. Let's walk through a real scenario. So say an attacker launches a zero-day exploit against a critical infrastructure control system. There is no signature. There's no predefined rules. The AI-powered system begins with data ingestion, collecting network logs, endpoint telemetry, and user behavior signals. Next, feature extraction transforms raw data into meaningful variables, session duration shifts, entropy changes, packet size variances, unusual privilege patterns. Behavioral modeling, often using unsupervised techniques such as clustering or autoencoders, establishes what normal looks like for the environment. Then deviation occurs. Privilege escalation, abnormal encryption activity, lateral movement across segments. Anomaly scoring spikes. According to the Center of Security and Emerging Technology, AI is transforming the vulnerability lifecycle by enabling earlier detection and prioritization of exploit pathways. At that point, the system executes automated containment. So it moves into endpoint isolation, credential revocation, network segmentation adjustment. This dramatically reduces both mean time to detection and mean time to respond. The key difference is this: AI detects behavior, not just known code. So let's ground this in real systems. Darktrace leans heavily into unsupervised machine learning. Their architecture builds behavioral baselines across networks. What they describe as an enterprise immune system, the differentiator is anomaly detection without predefined signatures. CrowdStrike takes a different approach. They apply supervised deep learning and models across massive global telemetry datasets, trillions of security events, enabling real-time classification at cloud scale. Palo Alto Networks integrates AI directly into enforcement layers. Their models operate inline within next-generation firewalls and cloud platforms, dramatically adjusting prevention policies in real time. 3 vendors, 3 philosophies, 1 common denominator: AI as the core detection engine. 3 distinct architectural philosophies emerge: anomaly-based behavioral detection, telemetry scale supervised modeling, and inline AI enforcement. Different designs, same objective: machine speed adaptation. And the evolution doesn't stop at detection. Codem Security describes the next evolution: agentic red teams, autonomous AI agents continuously simulating adversarial behavior. This shifts cybersecurity from reactive detection to proactive AI-enabled offensive strategy. From an infrastructure standpoint, that's not trivial. It requires scalable GPU compute, secure telemetry pipelines, model lifecycle governance, zero trust architectural principles. Security AI must be architected as core infrastructure, not simply deployed as software. The organizations that treat AI as infrastructure will outpace those that treat it as a feature. But architecture alone is not enough. It must translate into measurable advantage. How do we know AI in cybersecurity actually works? Well, we measure it. Things like time to detection, time to respond, signal accuracy, analyst efficiency, breach cost reductions. The mean time to detect tells us how quickly AI identifies abnormal behavior. The mean time to repair tells us how quickly the system contains it. Precision and recall determine whether we are truly protecting the organization or overwhelming analysis with noise. Ahmed and Taha remind us that false positives erode trust, just as false negatives increase exposure. Detection accuracy must balance both. When detection time drops, breach cost drops. When time is the currency of cyber defense, security becomes measurable, not just in logs, but in operational resilience. And At the executive level, the question simplifies to one thing: how fast can our digital bodyguard react? The next phase of cyber defense is predictive, and predictive changes the tempo of the battlefield. AI will accelerate exploit discovery. The Center of Security and Emerging Technologies notes that AI-enabled vulnerability research shortens the time between discovery and exploitation. Attackers will automate reconnaissance and vulnerability analysis at scale. At CSET, they suggest AI accelerates vulnerability discovery on both sides. That forces defense into an AI versus AI paradigm. Defense systems must continuously simulate adversarial behavior, and validate themselves in real time. Quantum security describes the emergence of agentic AI red teams, autonomous models that simulate adversarial behavior continuously. Testing becomes continuous, not quarterly. This is where the architecture evolves. In the coming decade, we move toward things like self-healing infrastructure, autonomous exploit simulation, continuous model integrity validation, AI-driven security posture management. This architecture is modular by design. Whether the target is critical infrastructure, banking, or healthcare, the defense AI framework remains consistent. AI becomes a portable strategic capability, not a sector-specific solution. In an AI-accelerated threat landscape, the advantage belongs to the organization whose defense learns faster than its adversary. AI will not simply assist cybersecurity teams, it will redefine how we architect digital defense. Organizations that architect AI security as core infrastructure will lead the next decade of resilience. The question isn't whether AI will defend the digital frontier, it's how fast your digital bodyguard can react. Thank you.